For today's video, I'm going to share my understanding about these different topics on the last 3 different weeks. Now, within the first week are Earth Coordinate System, Latitude, Longitude, DLAT, and DLONG. Second week were different types of map projections, chart produced under particular use, and the use of navigational chart according to its scale. And on the last week, are general information obtained from the navigational charts, including its symbol and abbreviations. Earth Coordinate System. A geographic coordinate system is a three-dimensional reference system that locates points on the Earth's surface. The unit of measure is usually decimal degrees. A point has two coordinates values, latitude and longitude. Latitude and longitude measures angles. What is the purpose of the coordinate system? This system allows one to indicate any position in the sky by two reference points, at a time from the meridian and the angle from the horizon. Of course, since the Earth rotates, your coordinates will change after a few minutes. What is latitude? Latitude is the measurement of the distance north or south of the equator. It is measured with 180 imaginary lines that form circle around the Earth east-west parallel to the equator. These lines are known as parallels. Longitude. Longitude is the measurement east or west of the prime meridian. Longitude is measured by imaginary lines that run around the Earth vertically up and down and meet at the north and south poles. These lines are known as meridians. Each meridian measures 1 arc degree of longitude. What is DLAT? DLAT between two places is the angular length of the arc of any meridian between their parallels. And D-long is the difference of the longitude between two places of the shorter arc of the two parallel, or the smaller angle at the pole between the meridians of the two places are on the same side of Greenwich. D-long is the numerical difference of longitudes of the two places. D-long is the numerical sum unless this exceeds 180 degrees, 360 degrees minus the sum. Four common types of map projections, and here are azimuthal projection, stereographic, conic projection, Lambert conformal conic, cylindrical projection, Mercator, and cylindrical projection, Robinson. Azimuthal projection stereo. Today, this is probably one of the most widely used azimuthal projection. It is most commonly used over polar areas but can be used for small-scale maps of continents such as Australia. The great attraction of the projection is that the Earth appears as if viewed from the space of a globe. Conic projection, Lambert. Today, the Lambert conformal conic projection has become a standard projection for mapping large areas or small scale in the mid-latitudes, such as USA, Europe, and Australia. It has also become particularly popular with aeronautical charts such as the 1 to 100,000 scale World Aeronautical Chart Series. Cylindrical projection Mercator. It became the standard map projection of nautical purposes because of its ability to represent lines of constant true directions. In an era of sailing ships and navigation based on direction only, this was a vitally important feature of this projection. Cylindrical projection Robinson. It was developed because modern map makers had become dissatisfied with the distortions inherent in the Mercator projection, and they wanted a world projection which looked more like reality. Charts produced under particular use. Cylindrical map projections are great for comparing latitudes to each other and are useful for teaching and visualizing the world as a whole. but really aren't the most accurate way of visualizing how the world really looks in its entirety. Conic map projections. Like the cylindrical projection, conic map projections have parallels that cross the meridians at the right angles with a constant measure of distortions throughout. Conic map projections are designed to be able to be wrapped around a cone on top of a sphere or a globe, but aren't supposed to be geometrically accurate. Conic maps projections are best suited for use as regional or hemispheric maps but rarely for a complete world map. Azimuthal map projection. The main features of azimuthal map projection are straight meridian lines radiating out from a central point, parallels that are circular around the central point, and equidistant parallel spacing. Navigational chart according to its scale. The nautical chart is one of the most important tools. A chart is a graphical representation of part of the Earth's surface. Unlike a map, a chart emphasizes areas of water and features that allow mariners to determine position, avoid hazards, and find a safe route to the destination. Information provided by the nautical chart. The first is title block. The title block includes information like title of the chart, date of survey, projection used, planes of reference, original authority, datum for sounding, and units of measurement. The use of color on charts. Colors are used to distinguish deep and shallow water, shoal water, land areas, and traffic separation scheme. The next is chart notes. Chart notes is used as a regulatory restrictions, cautions and warnings, and unusual magnetic conditions. The next is the lettering styles. The lettering styles include vertical lettering, dry at high water, navigational aids, rock and small islet, learning or slanting lettering, submerged and floating hydrographic features, tidal streams, rock and reef covered at high water. The next is the water features. The water features include check the title block for unit of measurement, datum for used for sounding, and contour lines or depth curve. Land features. Land information that are important or useful to navigators in establishing vessels' position and directing vessels' movement. This information include mountain peak with contour line, headlands, and shores. Here are some examples of symbol and abbreviations. All for today's video. See you next time. Bye-bye.